Okay, so hello and welcome to this new lecture in the ongoing series of lectures on printing inks. So as I had already discussed in the last lecture itself, that from this lecture onwards, I will proceed. First, I will start with manufacturing process, and then I'll be talking about the ink formulation, because you see it is very important for us to understand how the resin is actually made. I have been talking about cooking the resin inside of the oil and all this. So let us first get those idea clear, and then we will proceed, because we don't have any problem in studying or understanding manufacturing process at this point, because we know all the components that goes into making of the ink. So only the formulation part, that is what to mix at what percentage for what type of ink, that we will be studying a little bit later on after we finish this part. Okay, so normally you see there are three major steps in ink manufacturing. First, as you can see is here, first is the resin manufacturing, right? This is the first step. It, as I've already told you, that this resin manufacturing may be of both the types, that is vehicle manufacturing actually, oleoresinous type of vehicle and solvent resin based vehicles actually. Second one is your pigment dispersion, and the third one is adding the additives, various types of additives like plasticizers, dryers, wax, and all these type of additives when they are added for any specific behavioral change in the ink. Okay, so first let us start. I will not show you this because this may look a bit complicated. I've made it very simple like this. Okay, so now here we are talking about, this is not really resin, but this is, we are preparing the vehicle. We are manufacturing the vehicle, and especially we are manufacturing oleoresinous vehicle. Okay, we are preparing oleoresinous vehicle. So what happens? First we add the distillate. Distillate is the petroleum distillate that we already talked about. So it is like more likely to be a aliphatic hydrocarbon, right? Aliphatic hydrocarbon. So that is added to the tank in presence of nitrogen flow. Because why nitrogen? Because in order to prevent any type of because it is, nitrogen is inert in nature, it does not react with anything that is present within the reaction environment, right? Next we add the preheated alkyd. Now you know how this preheated alkyd, I mean the alkyd is prepared, alkyd resins are prepared. I will talk about alkyds in great detail when we are talking about the, when we are discussing the manufacturing process. But then we add the preheated alkyd. Then we add the hard resins. Hard resins, maybe phenolic resin, maybe rosin modified or malic modified resin. All this type of, any type of resin which is essentially hard in nature, like the small crystals I showed you in the other, in the earlier lecture. So then we add this hard resin and we heat it. Now this temperature and the time that is given over here, this will depend, this is not really fixed, this is not really constant. Okay, so this time and temperature, this will you know depend on what type of vehicle you are manufacturing using the specific type of resin. This will depend upon what type of resin you have used in your system, right? Then we have the gelent. Gelent is, I told you, these are basically aluminum based complex, which I referred to as chelates in the earlier lecture. So then we are adding this chelates. So chelates, what they will do, they will enhance the viscosity a little bit in the of the uh, vehicle. Then it is reheated after addition of chelates, and then finally if we need to change the viscosity a little bit, maybe the viscosity has gone up to a great extent, then we may add a little bit of distillate. So this distillate is purely added for the purpose of changing the viscosity really of the final product, and finally we will filter out the vehicle. Okay, we'll filter out the vehicle. So this is the entire process. I have another picture also. See, this is the time taken for manufacturing of the vehicle, and this is the temperature to which the various stages are heated during the manufacturing of the vehicle. So first is the charge. We are charging the, we are placing the distillate, which is the oil, which we can say these are mineral oils, or if you are using vegetable oil, then vegetable oil. So we are adding that to the chamber, or to the tank, then the resin is added. Charging means adding. So then resin is cooked because we are adding hard resins within oil. So it will change this hard resins. They will start to kind of become this thick, almost paste-like structure. Okay, so that is why this process is known as cooking. So this resin is cooked, and then after it has been cooked sufficiently, then this chelate addition will be there. Chelate will react, and the viscosity will go up a little bit. So notice how after the chelate addition, when chelate is added, the temperature of the system is lower, right? Now after chelate has been added to the system, then the temperature has been raised to this point, right? And then final addition of or alteration of viscosity with the addition of further distillates, and then you can go for final filtering into the drums and quality assurance and all these things. Okay, so this is your vehicle preparation. Now your vehicle is ready for manufacturing. Now what to do? Now you have to add or charge pigment and other additives to this vehicle. This is usually done in this trifoil. This is known as trifoil. Why trifoil? Because you see, this is essentially a drum or a pot, large pot, in which first you add the vehicle, in which then you add or charge the pigment, and finally you add the additives if as necessary. And there is a shaft which goes inside of this particular pot, and this shaft has got three legs actually. So that is why this system is known as a trifoil. You just simply mix all the pigment inside of the additives inside of that vehicle, right? Once this is done, then comes the part of the pigment dispersion, or what we colloquially known as the grinding process. So this grinding also, this dispersion can also be done in three methods. One, this type of a machine is known as a triple roll mill. See, it's written triple roll mill. That means there are three rollers essentially. Okay, and this is known as the bead mill. What essentially happens over here is that, in case I will show you a video which then you will be able to understand very clearly about the manufacturing process. What happens is there are three rollers like this. Let me just show you. There are three rollers like this. Okay, now what happens is the ink is dropped on in between the first and the second rollers, and these rollers are very large and heavy in nature. So naturally there is a certain amount of pressure and a certain temperature between these rollers. Ink is dropped between these two rollers, and the ink then passes not only between these two rollers but also passes between these two rollers and ultimately comes off from the third roller, right? There is a pot given on which the ink falls. The pressure and temperature at which the ink is exposed, along with the shearing forces that the rollers apply on the ink, this causes the pigment particles to get uniformly dispersed within the vehicle, and also ensures that all the pigment particles have got are broken down into smaller pieces and have got a uniform coating of the vehicle around itself. This will prevent coagulation and ensure that the pigment remains dispersed well throughout the vehicle, well throughout the ink. This is one approach. The bead mill approach, here you see there is a, I will show you the cross section. There are very small beads, steel beads actually, and the inside of this has got some teeth like this throughout the cylinder. Ink is made to pass through this, right? And this entire section in this entire cylinder is rotated very fast. So what will happen? These beads along with the ink will start to get agitated, and there is this teeth. Because of this shearing forces that apply on the ink, that is applied on the ink by these beads as well as on the teeth, the pigment particles get dispersed within the vehicle. So both these techniques, that is the triple roll mill and the bead mill, there is another mill known as ball mill. All these techniques, they are essentially, the main function is to ensure that the pigment remains well dispersed within the vehicle or the ink itself, and that all the pigment particles are coated with uniform coating of the vehicle. This will prevent coagulation and all this bleeding type of stuff. Okay. Normally you see the time taken in the bead mill is longer than the triple roll mill, but the quality of dispersion is much more fine, in case of your bead mill. That means the fineness of grind will be much lower, or I mean the micron value will be much lower in what is obtained from the bead mill than in case of your triple mill. So let us say one pass in the bead mill will be equivalent to maybe two passes in the triple roll mill, or three passes in the triple roll mill, depending on what type of ink and what type of pigment, what type of surfactants you are using in the ink itself. Right now, once the pigment has been dispersed well enough within the ink, then it again goes into the trifoil, this type of a machine, same type of a machine as it came. Here, further additives will be added for rheology modification, maybe some distillates, clay, all these things, some dryers, all these things will be added in this final stage. So in this stage, the pigment has already been dispersed within the ink. All that is left that to be done is to add these additives within the finished ink and then send it for pot off. Pot off means placing this ink into smaller containers for final final delivery to the customer. Okay, so yeah, this is another concept. Actually, this is known as uh, flushed pigment or pigment flushing. So the example that the manufacturing process that I told you in this entire thing, this is known as the dry color route of ink manufacturing. Dry color route of ink manufacturing, right? Why? Because the pigment comes in the form of powder. You are just simply mixing it in the in the vehicle and then sending it off for dispersion. But the concept of flushed pigment is little bit different. See, it is very difficult for us to get the pigment dispersed well enough within the vehicle, and that is why so many passes are required sometimes within the triple roll mill, and various surfactants are added to the pigment just to ensure that the pigments are broken down into small finer components and they are all dispersed or weighted uniformly with the help of the vehicle and remain dispersed uniformly throughout the ink itself. Now there is another process of ink making which is known as the flush route. This process involves preparation of something which is known as the flushed pigment. What is done? Now, normally the pigment component or the pigment which comes normally in the powder form, this pigment is surrounded, all the pigment, smaller pigment particles, they are surrounded by air around them, right? Like this. Because they are surrounded by air, it becomes very difficult during the dry color route, during pigment dispersion, to remove this air and to coat the pigment particles with the help of the vehicle. In flushing, what we do is we first wet the pigment with the help of some water. Okay, what happens is this water forcefully, when we are entering, when we are charging water forcefully inside of this pigment, this air around the pigment will get sucked away or removed, and this their place will be taken by water, so the pigment will become wet by water on all sides. Now, just before pigment manufacturing, just before finishing the process, what is done, through a vacuum chamber, this water is sucked off. So that means what? Now the pigment which was initially very difficult for us to get dispersed now, and it was surrounded by air on all sides, due to which it was difficult for us to to disperse it, now has got no air, and any remaining water will be sucked off through vacuum. This essentially creates a kind of a paste like thing which is almost ready for ink manufacturing. The last step involves removing, once this water is removed, so essentially again there may be a chance that the pigments will start to coagulate. Now, in order to prevent this from happening, what is done? Resin is charged inside of this pigment chamber. So what happens? The space which was initially covered by air and then water is now covered, or the pigment particles are now coated uniformly with the help of resin. That means what? That means it becomes very easy for us now to take that paste that of the flushed pigment and add or send it into the dispersion, add some additives and send it for dispersion. Now it will be very much easier. Why? Because that initial problem which we faced in the dry color route, that is, first we had to remove the air, then we had to disperse it multiple times or grind it multiple times just to ensure that each pigment particles were covered by the vehicle. Now that problem has been removed. So this advantage is offered by the flushed pigment, but there are certain disadvantages also. Water uptake, there is a major problem in some of the flushed pigments, but nonetheless this is a very widely used technology today, especially in mass ink production. Flushing is done of the pigments to ensure quicker manufacturing times, as well as very good dispersion of the pigment within the vehicle system, right? And after the flushing has been done and dispersion has been done of the flushed pigment, then you simply add the additives in the trifoil and you pot off. So this is another method for manufacturing of the flushed pigment, right? Now here you can see that in case of, this is a comparative statement that has been given over here, that this is normally, as you can see, this is normally the dry color route, times for the dry color route, time taken to manufacture for one single ink, one batch of ink in dry color route. The same for flush pigment. So which is lower? As I told you, naturally the time taken for the flush pigment to complete the production will be lower than that through the obtained through the dry color route. This is a major advantage. Manufacturing time is much lower for flush pigments. Okay, now next is the solvent based ink. So in case of solvent based inks, if you are using the dye stuff, then there is no problem for ensuring dispersion, because there is no concept of dispersion there. It will become a solution. But if you are using this pigment, then what will happen is this so whenever you are seeing this term chip, understand that this is the dye stuff. Chip means dye stuff comes in the form of chips or small stones like that. So once this is done, once you are adding this pigment within the solvent along with the resin and additives, etc., then that needs to be dispersed, not with the dye stuff but with the pigment. So in order to do this, what happens is the entire chamber within which the material has been placed, that is shaken vigorously or vibrated vigorously. Due to that agitation, due to that vibration, the pigment starts to get dispersed within the solvent of the vehicle component in the liquid ink. So this is a major difference in production of solvent based and paste inks actually. Okay. So in this picture you can see that what is the effect that certain dispersion process or manufacturing process has got on the ink. So here this is one single pigment that is used, rubyne PPC. So rubyne is one pigment which is used commonly for manufacturing magenta. So here the first situation is it has been made to pass for 15 minutes. Okay, this is what happens. So naturally you can see that pigment has not yet been dispersed, right? Pigment has not yet been dispersed. All these pigments are still coagulated, they are not been dispersed. So this is for 30 minutes and this is for 30 minutes with a second pass. Okay, second polish, second grinding pass. So comparative with the time, and as you increase the number of dispersion passes or grinding pass, whatever you like to call it, you see the nature of the ink has changed. That means the pigment has got dispersed properly with a greater amount of energy provided to the ink for the purpose of pigment dispersion. Okay, so this is the bead mill that I talked about. You see, the bead mill has got the inner surface has got these teeth, and there are certain bead also, right? So many beads, small steel beads actually, few microns in diameter. So when the ink and the ink is being passed, now this entire chamber is actually rotating. Okay, so what is going to happen? The beads will again cascade and it will agitate the ink, and the ink is made to pass through this within this teeth. This causes that agitation. This causes the abrasive forces on the, or shearing forces on the ink, which ensures that the pigment is dispersed well enough within the ink. This is what the your triple roll mill is looking like. So this is where the ink is made to fall, right? First the ink will pass through this roller combination, and then through this roller combination finally. The temperature and pressure can be adjusted between these individual rollers. That means this, there will be a set of temperature and pressure here, and there will be a set of temperature pressure here. So you can control both the temperature pressure uh, between the that is between two consecutive roller sections. And by changing this pressure and temperature, what happens, you can increase or decrease the shearing forces acting on the ink, and due to this the amount of dispersion will vary. So the degree of dispersion will vary, and depending upon what type of ink you have chosen, what type of you are making, what type of pigment and resin combination you have chosen, this temperature pressure has to be changed. So this is how the entire ink manufacturing process works. Now let us talk a little bit about the the formulation part of the ink. So yesterday in the other lecture, I talked about this general purpose black ink for letterpress printing, right? What is the formulation for that? So carbon black and reflex blue, these are both pigments. Long oil alkyd, this means alkyd resin, which has been cooked inside of, maybe normally this is cooked inside linseed oil. Okay, then we have got mineral oil, that is aliphatic hydrocarbon for changing for setting times, decreased setting times, and for changing the viscosity. Then we have got the varnish. So what is the varnish? Varnish is a hydrocarbon resin or a modified phenolic resin which is cooked inside of a linseed and mineral oil. Now you understand the concept of cooking. Then of course we have got a cobalt dryer and an antioxidant. Right? This is a very generic type of a ink formulation for letterpress ink. Next, let us move on to the next type of a printing. So this is again another thing I missed out. That is, what is the drying mechanism for letterpress inks? Primarily through oxidative polymerization, secondarily through penetration within the paper itself. Next, we have got the formulation for Coldset Web offsetting. So this is primarily through penetration and again secondarily through oxidative polymerization. Some amount is also left for oxidative polymerization. What is the formulation here? Carbon black. So this is all in percentage values, right? So this will be 18%. Carbon black, black pigment. That means this is black ink we are making. Then varnish. Varnish means a vehicle. So again, I have told you yesterday only. Now, from now on, I will use the term varnish and vehicle almost analogously. In some books they refer to as vehicle, and some books they refer to as varnish. So they here, at least for ink making purposes, they mean the same. There is another term for varnish which is sometimes used for over printing, overcoating. Overprinting coatings that are normally used for print finish operations, those are also referred to as varnish. But right now, varnish, when I say, consider that to be the vehicle actually. Okay. So next, what is the varnish? See, phenolic resin, that is gelled in alkyd resin. That means, you remember I told you in the cooking process that you are adding the distillate first, then the preheated alkyd, and then to that the resin. So here alkyd resin has been used, gelled alkyd resin nonetheless. This has all been cooked inside of soya oil, that is vegetable oil, drying oil. Then we have got the soya oil and the various additives that we have chosen. Okay. So the combination here for the varnish as well as for the the distillate. So this will act as the distillate essentially. So this is semi-drying oil. Both these varnish as well as your distillate, whatever you are using, they have been cooked, or the same type of oil has been used. This is something to be considered over here. Okay. Next, this is another type of, yeah, that last one was this black ink. This is a color ink. So we have used phthalo blue, that means it is a cyan ink. This is cyan ink, right? This is also written also process cyan using vegetable oil. Okay. So normally Coldset inks are made with mineral oils now. That is why often it is said that whenever this is very important, I would like to point it out here also. So let us say when you go outside to buy some food in the street shops and those what is it called, that quick food, those fast food, yeah. So these whenever you, let us say, you are buying something from those shops, they will often wrap it with newspapers, right? Do not use those newspapers as food wrapping materials, especially when you have got oily food. What happens is the ink, some of the oil that is still present in the ink, that can, and even the pigment particles also, this phthalo blue is not very healthy, obviously, for the human consumption. So all these materials can migrate into your food because there's a direct contact between your food and the wrappers, paper wrappers. So try to avoid the use of these newspapers as food wrapping materials, especially. Okay. So yeah, so then we have got extended. Extender is what? Calcium carbonate is good example of extender, right? So extender will do what? It will increase the bulk of the weight of the ink without changing the optical properties of the ink. So the varnish is what? Phenolic resin cooked in gelled alkyd resin and soy oil, then again gelled. So not only the alkyd resin while manufacturing, not only the alkyd resin has been gelled, but during the manufacturing of this varnish also, this varnish has also been gelled in the final stages of its production. Then we have got refined soy oil and some additives. So again, this primary method of drying is penetration and some amount through oxidative polymerization. Okay. Now, here you see there's a very important consideration, formulation consideration, that what is the effect of certain components that is present in the ink in the various printability issues during the manufacturing of the Coldset web offsettings. Okay. So a higher grade indicates stronger influence. So 5 indicates a stronger influence than 1, right? So like that. So say pigment. What is the effect of pigment on rheology? Very high indication, a very high influence. What is the effect of pigment on tack? Low indication or low influence. What is the indication of pigment, influence of pigment on ink found relationships? This is high. So the thing is, can you tell me why this is important for us to understand, or why this is important for the ink maker also to understand? Because you see, let us say you are preparing a ink which requires um, which is to be used for cold set printing, right? Cold set web offset printing. So naturally, for cold set printing, the primary target is the setting times should be quite high because the speed of the web is very high. If the setting is not quick enough, then there might be problems of set off and the ink. Also, the ink should not be penetrate the paper, or it should not be absorbed so much that show through problems occur, right? So that is why all these factors, all these components that goes into making the ink has got influence in determining the various characteristics of the printed ink. Okay. That is why it's important for us to understand. Now this is another type of uh, ink which is known as the heatset. So let me talk about the heatset ink here for a minute. Your heatset printing technology will be discussed by Keith sir in your I think other plano or offset printing techniques, etc. But from the ink perspective, let me talk about the formulation here for a minute and why a specific formulation is suited. Let us first talk about so here both the flush based and the dry color route both have been given, and all the ink component, I mean all the processings have been provided as formulation part. First, in dry color route, as we all know that we are using dry pigment, right? Then we have got medium gel heat set varnish. Okay, before I talk about the formulation here, I just want to talk a little bit about the heat set printing process itself. What happens is normal web offset printing machine, but after it has been printed, after the web has been printed completely, then it is made to pass through some heating rollers. The web of paper is made to pass through some heating rollers, okay, and the temperatures are progressively increased and progressively decreased, okay, and after that there is another stack of chiller rollers. That means the temperature is again reduced. The temperature of this wave is increased due to the fact of the presence of some uh, non-volatile solvent that is present in the ink. And as I have already told you in the earlier classes, that heats the primary method for drying of heat-set wave offset ink is through evaporation, and then through penetration and oxidative polymerization a little bit. What will evaporate? That non-volatile, again I am repeating, non-volatile solvent will evaporate. Non-volatile solvent will evaporate from the ink when you are making the web, printed web, to pass through heating rollers. As soon as the solvent material evaporates, you will be left out with the solid component, that is the resin and the colorant and all this. So they will be coalescing, and they will be any residual amount of solvent that may be present, or distillate that may be present, that can penetrate within the paper itself. Okay, so this is how heat-set wave offset operates. Now here you see, after dry pigment, what is there given? Medium gel heat-set varnish and gel heat-set varnish. Now let us take a look at the vehicle formulation, or the varnish formulation of these heat-set inks. First, we see that maleic resin based heat-set varnish. So the rosin has been modified using what? Using your maleic anhydride that I had already shown you earlier. So this is that resin, maleic modified resin, and then we are using high viscosity soy alkyd. High viscosity. Okay, so another concept is there, that is I showed you earlier also. This concept of high viscosity and low viscosity alkyd. How does it matter, and why you should be considered? There is also another name. I think it is known as long oil, short oil. Okay, what does all this mean? High viscosity alkyd means the ratio of oil is to alkyd. This is very specific. That means the quantity of alkyd is higher in comparison to the quantity of oil used during manufacturing of that alkyd resin. This is sometimes known as short oil alkyd. Okay. Now, another type of alkyd, that is low viscosity alkyd. Here, just the reverse happens. That is, the quantity of oil is greater in comparison to the quantity of alkyd. This is sometimes referred to as long oil alkyd. So naturally, if the quantity of, or the amount of oil during cooking of the alkyd resin is higher, alkyd is a resin. It is very thick. It is very highly viscous material, right? So if that material is added in smaller quantity and the oil is added in larger quantity, naturally the viscosity of the alkyd resin will come down, because the liquid component, that is oil component, is higher than the solidus component or the paste component, right? Conversely, if we are adding greater proportion of alkyd, that is the high viscosity component, in comparison to oil, naturally the ultimate output, that is the alkyd resin, cooked alkyd resin that you get, the viscosity for that will increase, because it has got a greater proportion of the alkyd resin in comparison to the soy oil, right? So this is the concept of high viscosity soy alkyd and low viscosity soy, because this will come again and again. You will see in the preparation of quickset varnishes also, right? So this is another alkyd. So alkyd, what is the specific function of alkyd? I will come to that specifically in next 1 or 2 slides. Okay. So then we have got, and this is very important both for your quickset inks as well as for your heatset inks. This is aromatic free distillate. What is this temperature range? This is the boiling point range for the distillate. So that means this is essentially a aliphatic hydrocarbon based distillate whose boiling point ranges between 260 degrees Celsius to 290 degrees Celsius. So you need to raise the temperature of your heating rollers such that this component, that is this aliphatic hydrocarbon or this distillate, evaporates at near about that temperature. But conversely, if I say if you use a aromatic hydrocarbon over here whose boiling range is much lower than this particular distillate, then you do not need any heating rollers. Automatically it will evaporate out. That we don't want. That is These type of formulations we use normally for gravure printing, where even in absence of your heating rollers, the solvent may evaporate, where you use aromatic hydrocarbons in the formulation for gravurings. I will show that also. And ultimately you have got this aluminium chelate. See, here you see, so this is the basic varnish formulation for your heatset ink. Here you see the two things are written. First is medium gel heatset and high gel heatset. What is the meaning of this medium gel and high gel? The amount of chelate that has been, or the amount of gellant that has been added, those aluminum complexes that has been added to increase the viscosity of the ultimate varnish, cooked varnish, that determines what will be the viscosity of the varnish. So this high gel viscosity, high gel heatset varnish, naturally from the name itself it suggests that the viscosity of this component is higher in comparison to your medium gel varnish. Then you have got low viscosity linseed alkyd, again another cooked alkyd is given. Then you have got PE wax, PTFE wax. Why? Because normally as I already told you in the earlier class also, that wax improves the surface property. Now the question is, why is it important for us to increase the surface property of this heat setting and not cold setting? Now imagine what is the surface or what is the substrate on which cold settings are used? Newspaper, SNP, like that. But what is the surface on which heat settings are used? Maybe GNP, maybe gloss art, or maybe gloss web. So these type of materials, when the gloss of the or the coefficient of friction is quite less in your substrate, then we need to improve the surface property of the ink as well, so that it does not get rubbed off from the surface of the printed surface of the substrate. That is why we add wax in all these inks. Then we have got heatset flush, right? Some flush is added to this in only you see in the black ink itself, not in other colored inks, because this is a manufacturing choice that some manufacturers use, because due to certain improving the manufacturing efficiency, that's all. Okay. And then again we have another aromatic free distillate with a temperature of 240 to 270 degrees Celsius. So consider this, that the boiling range of this distillate is lower. That means what? You need a relatively, when you are applying some heat onto your roll, if that heat is so high, then there is a chance to burn off the surface of the substrate. So you need to use a distillate whose boiling range is optimal, so that only increasing the temperature of the heating rollers to a certain extent you can get good result in the sense that most of the distillate will evaporate out. That is the reason of using distillate which is relative. In case of your quick set, you will see we are using aromatic free distillates whose boiling range is very high. There you don't need this type of heating mechanism. It will dry primarily through oxidative polymerization. But since in case of your Heatset Web, you need heating, external heat to dry off this solvent component, that's a distillate component. That is why you need to choose a distillate having a boiling point range optimally set, such that a comparatively lower amount of heat can lead to evaporation of that distillate. And finally, we have some sequestering agent. Sequestering agent is another name for some specific chelate agent, depending upon the pH, what type of pH the agent has, what type of acidity the pH provides. That is why some chelating agent is provided. Due to this, there is another problem that occurs, especially as you can see, the sequestering agent is added to magenta ink. Because of presence of these type of materials, and as well as the nature of the magenta, those rubine pigments itself, another problem occurs specifically in magenta inks during print production. That is known as roller blinding, I think. What happens is the calcium components or these metals that are present within this magenta ink, after a very long period of time, the metering rollers that is present in the magenta printing unit, they start to, it's made out of rubber itself. So the pores of that rubber surface starts to get filled out with these metals, and it becomes very much glazed. That means it cannot hold out the ink properly. It should be able to, what is the purpose of metering roller? It should be able to hold out the ink onto its surface and ensure a smooth layer of that surface, a uniform layer of that printing ink, and able to transfer it to the next roller. So if, but this is only possible when it is deglazed. That means when it is relatively rough surface, there is peaks and valleys are there. But if these peaks and valleys are, covered by these materials, then it will not be able to hold out that ink and transfer it to the next roller. That is the problem actually. Next, yes, here we study a little bit about this. What are the considerations in terms of two things? One is the hydrocarbons, I mean the distillates, as well as another alkyd. So, what is the purpose that I have given over here? See, rosin modified phenolics with higher melting point will have higher viscosity, low tag, poor gloss, fast setting, good solvent release, poor pigment wetting. Okay. Now consider this very here for a moment, because this is going to be very important. See, it is said that higher melting point, yeah, so higher melting point phenolics will have poor gloss and fast setting. From here itself it is clear the relationship between gloss and setting are opposite to each other. They are inversely related. That is, a ink which is, or a varnish which is offering high gloss, that cannot work as a faster setting, or that cannot be used for making a faster setting ink. Conversely, a varnish which is offering faster setting times cannot be used for preparation of ink which whose requirement is to provide good gloss. Okay, why this is the fact, you may ask. See, gloss is how much you are able to hold out the liquid component of the ink, or the distillate component of the ink, on the surface of the paper, such that all the peaks and valleys of the paper are out of view. That means a uniform layer of that high viscosity component of that ink will cover the peaks and valley, and there will be regular reflection, or what we call as specular reflection, giving a very glossy appearance. But for inks which is having faster settings, there we need to have some component which immediately penetrates into the paper, or penetrates inside of the surface, preventing any sort of set off. So that is why they are both antithetical in nature. So why I am saying this is important is, in quick settings, how do they dry? They have two phases. One phase ensures setting, that is immediately this gets penetrated into the, gets absorbed into the paper. These are normally your high boiling range aliphatic components or aromatic free components. And the other type of varnish that is used that provides gloss, that will hold out on the surface of the paper for a longer period of time, and they will dry with the help of oxidative polymerization, aerial oxidation. That is why it is important to understand this fact that in order to prepare any ink, there may be more than one resin, and most importantly, there may be more than one varnish that is required. As you can see here, multiple varnishes are required. Multiple varnishes are required for preparation of a single ink. Now let us talk about the subject of alkyd. So you know what alkyds are. What is the purpose? Purpose is for improving the pigment wetting property of the varnish. Alkyd resins are produced by reacting a dibasic acid with a polyol and drying oil. This you have already seen in the resin component. Here you see, the oil length of an alkyd resin is defined as number of grams of oil required to produce the 100 grams of resin. As oil length of the resin increases, generally the viscosity decreases. Does it match with what I told you here? That is, if the oil amount increases, right? If the oil length increases, then what is happening? The oil is increasing, alkyd is reducing. So this is known as a long oil alkyd, and the viscosity for that type of alkyd resin will decrease because the oil component is high. For such alkyd resins, the hardness of the film decreases, film flexibility increases because it is more low viscosity. Therefore, naturally, the film flexibility of such alkyd resins will also increase, and water resistance is reduced. water uptake increases. So this is another problem you can say for alkyd resins. So pigment, again you can see that pigment wetting, you can use pigment wetting properties of the alkyds. But again, water resistance is reduced means what? The water uptake capability. I will talk about water uptake capability when I talk about those emulsification tests. Ink should be able to, during in the image area of the plate, what is the emulsion that is formed there? That is water in ink emulsion, right? That means main dispersion medium is ink, within that some very small amount of water. But if the capability of the ink, or if the ability of the ink to uptake water is increased, then that emulsion will be destabilized, and naturally that balance of ink and water will get destabilized and scumming will occur. This is another problem that can occur. Okay. Next, gelanes are used to increase viscosity and yield value. Yield value, I think I already gave you some idea in your MQC lab, but we'll study in detail in this next component actually. While reducing gloss and viscosity, water uptake. Okay. That is the general purpose of gelate. Now, here you see what is the effect of this type of curves we call them as tag stability curve. We can calculate this curve by running your vehicle, or running your varnish or your finalized ink through a machine known as, I will show you the examples also, known as inkometer, which is used for the measurement of tag in the ink. Okay. So you see what is the effect of using a slow distillate and let us say, first let us talk about this a little bit. What is the effect on the tag of the ink when you are using a aromatic free distillate and a regular distillate? What is the impact there basically? Now first let us understand what is the impact of tag in printing first of all. See, essentially what tag means is, tag for any ink means is, it refers to the stickiness, basically stickiness of the ink, right? So tag is essential for the purposes of transferring of the ink from one roller to the other, right? So we don't want that tag to decrease to a great extent. If it decreases, then the transfer from one roller to other roller will not take place, right? And we don't want the tag to increase also to a great extent. Why? Because if tag increases, then the tendency of the ink to hold on to the preceding roller will increase. That stickiness to the other preceding roller will increase. So when it comes in contact with the succeeding roller, metering roller of the printing press, then it will not try to get transferred onto the succeeding roller. Even during printing, when if the tag of the ink is very high, then it will try to hold out in the blanket and substrate interface or interaction. There, if the tag of the ink is very high, then the ink will try to stick to the blanket itself. When the blanket, the inked blanket comes in contact with the substrate at the nib, even if the ink comes in contact with the substrate, it will not try to release the paper, and there will be problem of paper tearing. In case of your web machines, web break and all these problems will happen. Now if during printing at that blanket substrate interface, if the tag is very low, then there will be these problems of dot gain and instability, all these things will happen. So we want tag to be at optimal level. We don't want a very huge increase in tag, we don't want very sudden drop in tag as well. That is why over a certain period of time, we need to measure what is the tag of the ink, what is the change in tag of the ink, right? So such a curve is given over here. This is increasing in time, in minutes, and this is the increasing value of tag. Okay. Here you see two distillates have been given, two you can say varnishes have been prepared. One using a regular distillate, that means this contains aromatic hydrocarbons, and the other distillate does not contain aromatic hydrocarbon. There is aromatic free hydrocarbon, distillates. Okay. So what is the effect of both these distillates on the tag stability of the varnish? If it is very essential not only to measure the tag stability or the tag of the finalized ink, but it is also necessary for us to measure the tag of the varnish as well. So as I already told you, resin is the heart of the ink. If the property of the resin, varnish is what? Varnish is nothing but the cooked resin. So if the varnish property is not what is required, then naturally it will not the final ink will also not have the properties that you are looking for. So it is also essential to measure all the properties of the varnish before making the finalized ink. Okay. So as you can see over here, it takes a very long amount of time to increase the tack of this regular distillate, but what it does is there is overall increase in the tack of the, the varnish which is having regular distillate, right? So very high increase in tack. But in case of your aromatic free distillate, the tack increases but not to that extent, and of course the stability is also very much smooth, but the stability is very good. You might ask that why does this happen? The reason is because this has got regular distillate. That means this has got aromatic component in it, which is volatile in nature. Aromatic components are volatile in nature, and during measurement of tack, these aromatic components starts to evaporate out from the system, from the varnish, leaving behind the greater component of the resin and the gelatin and all this. This is why the stickiness of the ink increases, resulting in increase in tack. So this we don't want. This is unwanted. But this curve is much more smoother, and the increase in the tack value is also not that high, as you can see in case of a regular distillate. Okay. Again, another example is that what is the influence of the boiling range, right? Boiling range influence, here you can see two terms, that is fast distillate and slow distillate. So that means the boiling range for this fast distillate is very high, sorry, is very low, and the boiling range for the slow distillate is very high. Okay. This means that the tendency of this one, again these are two varnishes, one is made from a fast distillate and another is made from a this slow distillate. So what does it mean? That when you are using a fast distillate, its boiling range is low. That means there is a tendency for that distillate to evaporate out at lower temperatures. As the liquid component evaporates, the tack of that ink increases, right? As soon as it increases, after a certain time the body of the varnish breaks, that is that phase separation occurs, as a result of which the tack also drops down. But in case of a slow distillate whose boiling range is high, that solvent or that distillate does not evaporate that easily, resulting in this smooth and very uniform type of tack stability curve. So this is always preferable for our work, especially for quick set operations. It is very preferable. Okay. Hopefully this was a very important slide. Hopefully this is clear. Yes. So this I will not go into a lot of detail over here, but what I will do is I'll just talk about this component over here, this part over here. Okay. In this chart, what I have done is what is the effect of the resin, effect of the individual components on the various parameters, right? So what happens is if you go on increasing, if you go on decreasing the resin solid, the film hardness decreases. Okay. If you and then again, if you go on decreasing that resin solid, the tack decreases. What is the effect of distillate? If you increase that distillate component, then it viscosity decreases, and as well as pigment wetting decreases. Now, can you tell me why did I say all these things? I think it's pretty much clear. It's common sense that why resin solid will decrease the film hardness and distillate increase will decrease the viscosity. As you go on increasing the liquid component, the viscosity of that ink will decrease only. But can you tell me why it becomes very difficult for us to ensure good pigment wetting when we are increasing the distillate quantity? Think about this for a minute. Okay, next, this high solvent power distillate, aromatic type solvent or distillate, this increases, viscosity decreases, tack becomes optimum, and gloss increases. Okay, so this is the effect basically. So this is somewhat similar to this earlier slide I showed you for your cold setting. This is that same thing that is used, that can be obtained for heatset machines actually, or heatset inks for the matter. Okay, now this, what I really wanted to talk about is this component over here. See, what is the boiling range of the solvent, of this aromatic free solvent, and which type of ink it is used in. Okay, see, as the boiling range decreases. This is lowest boiling range. They are used in heatset. Why they are used in heatset? Because as I already told you, heatset uses additional external heat to increase the rate of evaporation of the solvent component and ensure ink drying. That is why if the temperature of the boiling range of that this distillate is very high, then it will require very high heat to evaporate that. We don't want that. At a very high heat, it can burn. It can the paper can catch fire. So that we don't want. Okay. Then as we go on increasing the boiling range, essentially, this highest boiling range is used for preparation of your quick setting. Okay, now let us talk a little bit about the, yeah, this is another curve. As I told you that the heat, when you are heating the this your paper, that is the roll, using heating rollers, you are generally raising gradually raising the temperature, and during heat, I mean during cooling also, you are decreasing the temperature of the roll using chilling rollers gradually. Why? Because suddenly, if you change the temperature at 20 degrees Celsius for a web of paper which was heated to around 150 to around 200 degrees Celsius, then what will happen? Immediately it will crack. The film, ink film will crack, the paper will also crack. Sudden, this evaporation of all the water or the moisture component from the paper will cause the paper to crack, as well as that is true for the sudden this thing for the ink also, sudden release of all the liquid component from the ink also, so it will crack. So that is why chilling is done very slowly for the heated rollers in heat.